All right, just a reminder, remember this is review section 12.4, part B. So if it says subtract 2x squared minus 3x plus 4, that's a 4, from 7x minus 6x squared plus 1. All right, so how would you do that problem on your final, if they do have that on your final? What'd you do? So you write that second polynomial first, right? So you'd say 7x minus 6x squared plus 1. And then you're subtracting this polynomial. Don't forget to put that in parentheses, though. 2x squared minus 3x plus 4. So remember, if you mistakenly leave the parentheses off of that second one, you're gonna have some errors. Okay, so that's what we have. Now what are you going to do? Now is where you get rid of the parentheses. Right, so the first one I can just remove. And remember, you can also think about this like the distributive property. What number is in front of this first parentheses? 1. And then 1 times anything is itself. So that's just 7x minus 6x squared plus 1 over here. What number is in front of this parentheses right here? -1. So you'd say -1 times 2x squared is a what? -1 times a -3x is a positive 3x, and then -1 times a positive 4 is a -4. And then at that point is where you combine like terms. And let's put them in descending order. So what exponent is going to be listed first? What's the largest exponent you see? X squared, okay, 2. All right, so I have a negative 6x squared and then a negative 2x squared. What does that give me? Okay. All right, then the next one will be your x terms. I have a 7x and a 3x. 10x. And then your constants, 1 and a -4 is a -3. All right. Okay, number 2. All right, suppose you had this in number 2. Suppose you had 7x minus 4 minus, and then let's say it's a negative 3x squared plus 6 minus 2x, and then plus x squared minus 5x plus 7. All right, suppose you had those. Now, how many polynomials do you see here? 3. Okay. So this is where you're going to get rid of the parentheses. So the first one, what does that become? Huh? Yeah, so if I get rid of the parentheses, that's just going to be what? Okay. Now, be careful with this one. What do I do with this one? So you're subtracting this polynomial. So that's where all these signs in here do what? Change. Now, do I change these signs also right here? No, because what are you doing to this one? You're adding. All right, so this is the only one that you're going to change. All right, so what does that become? Is it 3x squared minus 6 plus 2x? And then over here, that just becomes what? Yeah, so just rewrite it. Okay. All right, let's put it in descending order. So let's talk about the x squareds. What's 3x squared and x squared? 4x squared? Okay, now the x terms. 7x and 2x is what? 9x, and a negative 5x is 4x. All right? Now your constants. What's a -4 and a -6? And then what's a -10 and a +7? -3. All right, there's your answer. Okay? All right, so that should help you with that worksheet. Don't forget there's a back part though. Some of you keep forgetting about the back page. So remember, it's not always going to say remainder problems on the next page. So you got to look. Okay? All right. Now notice the direction says write your answers in descending order for numbers 1 through 8. So 1 through 8. Now, if you look at 9 and 10, you have different variables. So that's why I didn't say write in descending order. But the others, there's just one variable involved. But 9 and 10, you have 2 different variables. So you just combine them in any order you want to. Does not matter, and you're done. But remember, the ones you're adding 2 polynomials, and then this one you're subtracting a polynomial from another. Okay, so that was part B. So that's going to be due the last class period. Last class period. So make sure you have that for the last class period. Okay, the next thing I want you to take out is 12.6 part B. I'm sorry, 12.6 part A. 12.6 part A. Take that one out. Okay, that was where we started talking about the FOIL method. All right, so remember, FOIL first, the O stands for outer. I stands for inner, and L stands for last. And remember, you use the FOIL method when you're multiplying what type of polynomials? 2 binomials. So all of these are binomials, front and back. They're all binomials. Okay? Now, so just as a reminder, so the directions, now remember in your study guide, the last set of problems says FOIL. So FOIL is on your test 4. All right, and I can't remember how many problems I said. Maybe one, or there has to be at least one. Might be 2. I'm not sure.
1.
Just 1? Okay. So review. Section 12.6 part A. So you're going to multiply. It'll say multiply, and then will say use FOIL. Now the one in your final, you can use either distributive property or FOIL. It's not going to specify which method to use. So let's say you want to multiply. And let's say this is 3x minus 7 times 5x plus 4. And we're going to multiply these using a FOIL. Now notice the directions here, and that's important. The directions here show the 4 terms as presented in class under the problem, and then put the simplified answer in the blank. All right, so here's what I'm talking about. So when I do the FOIL, the first, F stands for the first term of each binomial. So the first term in this binomial is 3x. The first term in this binomial is 5x. So you're saying 3x times 5x is what? 15x squared. All right. The outer, so the terms on the outside of those 2 binomials, so 3x and positive 4, what do you get when you multiply those? Okay. And then the inner terms, the inner, so a negative 7 and a positive 5x multiplied together is a, and then your last term, the last term of each binomial, negative 7 times a positive 4 is a negative 28. So that's what I'm talking about. So that's what I want to see. So when it says on that worksheet, show the 4 terms as presented in class, that's what I'm talking about. So first, outer, inner, last. Okay? And then the simplified answer is when you combine your like terms. So it also says, okay, I was looking to see if it said put in descending order, but it didn't. Okay, so you're going to get 15x squared, and you can combine the outer and the inner. So what's a positive 12x and a negative 35x? Negative 23x, and then minus 28. Okay. All right, now let's look at number 2. So number 2, just a reminder. So what if you had this? What if you had 7x minus 2, let's make it 3y squared. 7x minus 3y squared. How would you, first of all, rewrite this? You're squaring a binomial. How would you rewrite it?
7x minus 3y times 7x.
Okay, so you're going to multiply the binomial times itself. And then you do the same thing, first, outer, inner, last. So when I look at the first terms of each binomial, what's 7x times 7x? Okay, what's the outer? What's a 7x times a negative 3y? Yeah. All right, now since I'm squaring a binomial, we talked about this last class period, since I'm squaring a binomial, the outer and the inner will be identical, right? So when I do the inner, what's a negative 3y times a positive 7x? It's also negative 21xy. And then the last terms of each binomial, what's a negative 3y times a negative 3y? Yeah, so a negative times a negative is a positive. So it's positive 9y squared. So that's the 4 terms I'm looking for. First, outer, inner, last. And then your simplified answer would be 49x squared. Okay, what's a negative 21xy and another negative 21xy? No, not xy, not x squared, y squared. It's just negative 42xy. It would be x squared, y squared if you were multiplying x by itself, but you're not. What are you doing to them? You're adding, okay? All right, and then plus 9y squared. All right, and then number 3, suppose you had 6x cubed minus 2 squared. 6x cubed minus 2 squared. What does that become? How can you rewrite that?
6x cubed minus 2 times itself.
Yeah. All right, and then use FOIL. So you got to be careful though here. You got to remember when you multiply like bases, what do you do with exponents? You add them. So what is 6x cubed times 6x cubed? 36x to the 6. Your outer. What's 6x cubed times a negative 2? Okay. The inner. What's a negative 2 times 6x cubed? All right, it should be the same because I'm squaring a binomial, right? So the outer and the inner will be the same. And then what's the last? What's a negative 2 times a negative 2? Okay. All right, combine like terms. What do I get as the simplified answer? All right, what's a negative 12x squared cubed and another negative 12x cubed? And then plus 4. All right. Okay. So that we talked about that last class period. So again, this is 12.6 Part A, due on the 29th, the last class period. Okay. Now remember though, this is on your test. That's on your test Thursday as well. There's one problem where you have to use FOIL. All right. Then the next thing I need for you to take out is the one that looks like this. 12.5 Part B. So take out 12.5 Part B. All right, 12.5 Part B. Okay, so, so 12.5 now remember 12.5 part A is what you had to turn in today. So that's where you have to use the distributive property. 12.5 part A. That's probably what you turned in. 12.5 part A. Here's the key to 12.5 part A. Stephanie, you turn in 12.5 part A? Okay. Here's the key. Did I give you the key to 12.5 part A? You can put it in the corner.
Yes.
Okay. So 12.5 part A is where you have to use the distributive property. Okay, so notice the directions here say this time, and that's important. You got to know both methods when you get to college algebra. But you see how I have two binomials here? Don't use the FOIL method. I want you to use the idea of the distributive property. Now, the FOIL method is a version of the distributive property, but that's not what I'm looking for here. I'll show you what I'm looking for. And we talked about this last class period. So if you go back to those notes, that on that table, you see what I'm referring to. So it says multiply using distributive property. Show the first step I presented in class. So I'm about to show you, and from the last class period as well, how to receive full credit. Do not use FOIL. If you do, you will receive no credit. Problems 1, 2, and 3 are 2 points each. Problems 4 and 5 are 3 points each. Okay, so here's the idea. So this is 12.5. Part B. Okay, so you're going to multiply. Okay, number 1. All right, suppose we had 7x minus 3 times 5x plus 8. All right, now don't use the FOIL method here. This is what I'm asking you to use if you remember what we did last class period. If I cover that second term right here, this kind of looks like I'm saying 7x times this, right? Mm-hmm. And so you're going to say 7x times this second binomial, and at some point you're going to use the what? Distributive property. That's what I'm referring to. So your first step is going to be this. You're going to say 7x times 5x plus 8. That's your first steps at this point. Okay? Then you're going to cover that 7x, but what else has to be multiplied by that second binomial? Negative 3. So you can say minus 3 times what? 5x plus 8. So that's that first step I'm referring to. Okay? That's that first step. Now the next step you have to do is to use what property? Distributive property. So what is 7x times 5x? Okay. What is 7x times 8? 56x. Okay. All right. And then what's the negative 3 times 5x? Yep. And what's the negative 3 times 8? All right. And then finally the last step is to combine like terms, and that's what you would put in the interblank. All right. And I didn't say anything about putting in descending order, so but let's just go ahead and do that. Let's just put in descending order. So I have 35x squared. All right. Now when I combine the out and the inner, what's 56x? And remember, you have access to a calculator. What's a positive 56 and a negative 15? 41? Okay, so it'll be plus 41x, right? And then minus 24? Okay. All right, number 2. Okay, number 2, suppose we had this. Suppose we had 5x plus 7 times 2x squared minus 3x minus 6. Okay, now before we go on, and number 1, if you were not told how to do this, you could have used the FOIL method in number 1, right? Mm-hmm. All right. But in number 2, could you use the FOIL method in number 2? No. You can only use the FOIL method if you're multiplying two binomials. So the way you're going to do number 2 is the way we did number 1. So when you go back to that worksheet, You see where it says numbers 4 and 5 are 3 points each? That's the one where you have a binomial times a trinomial. All right, so that's what we're looking at right now. All right, and all you do is just kind of the same thing. So I'm gonna cover up that 7. You're gonna say 5x times what? Yeah, very simple. And then I'm gonna cover the 5x, and you're gonna say plus what? 7 times that second polynomial. 2x squared minus 3x minus 6. So that's your first step. Okay, so that's what I want to see when I say that first step. You understand what to do with that one? Yeah. Okay. Now, the one in your final, it's usually two binomials, and they don't specify what method to use, so most students will use the fall method. But you do need to know that for next semester, though, and the semester after that. All right, and then what's the next step we have to do? No, we cannot yet. Distribute first. So what's 5x times 2x squared?
10x cubed.
10x cubed. What is 5x times a negative 3x?
Negative 15x squared.
15x, negative 15x squared minus 15x squared. What's 5x times a negative 6?
Negative 30x.
All right. Now the next one. What's a positive 7 times 2x squared?
14x squared.
What's positive 7 times negative 3x?
21x.
Minus 21x, right? And then what's a positive 7 times a negative 6? Negative 42. So that's what I have. And then finally, the last step is to combine your like terms. Let's just go ahead and put in descending order. So that x cubed, can I combine 10x cubed with anything else? No. So I'm just going to rewrite it. All right, now let's go by the x squareds. So I have a negative 15x squared. I can combine it with yeah, and what do I get?
Negative x squared.
Minus x squared, good. All right, and then the x terms. What's a negative 30x and a negative 21x? Negative 51x. And then the constant is just minus 42. Okay? All right, and then let's do one more where we have a binomial times a trinomial. So number 3, suppose you had 2x minus, let's say 9, times 4x squared minus 6x plus 1.
The same thing.
All right, what will be your first step, though? What would you write on that worksheet that we're looking at? What would be that first step you would have to say to get full credit?
2x.
2x times the trinomial, correct? 4x squared minus 6x plus 1. And then what?
Negative 9.
Minus 9 times 4x squared minus 6x plus 1. So that's your first step. That's what I want to see. Okay? Then what's the next step? Distribute. Okay, what's 2x times 4x squared?
8x cubed.
All right. What is 2x times a negative 6x?
Negative 12x squared.
Negative 12x squared.
Sorry.
What is 2x times a positive 1?
2x.
All right, so that takes care of that first distributive. The next one, what will you distribute over here? Negative 9. So what's negative 9 times 4x squared?
36.
Negative, right?
Yeah, negative 36.
X squared. What's a negative 9 times a negative 6x? Positive. Positive 54x. Remember, negative times a negative is a positive. What's a negative 9 times a positive 1? All right, and then finally combine like terms. Let's put the x cubed first. Can I combine x cubed with anything else? I'm just going to rewrite it. All right, now the x squared. So what's a negative 12x squared and a negative 36x squared?
Negative 40.
Negative 48x squared. And then your x terms, what's a positive 2x and a positive 54x?
56x.
Okay, and then the constant is
9.
minus 9. All right, so any questions on how to deal with this worksheet? All right, so remember, make sure you follow the directions. right, that first step, you know what I mean by that first step. Okay, so again, that's going to be due the last class period. Okay, now, one of the worksheets you turned in last class period had to do with graphing. So let's kind of review this. Okay, so let's suppose you want to graph y, let's do number 1, y equals negative 3/4 x plus 2. Negative 3/4 x plus 2. And you're going to do this using a t-table. That's the way we did it. We did a t-table, and you're gonna plot how many points? 3. You really need how many points to graph a line?
3.
No,
2.
2, but you could have made an error at one of them. So always do 3 to just make sure they all are collinear. They lie in the same line.
That's -3/4.
Yeah, it's negative 3/4. One of the nice numbers to use, now you see how y is by itself? That's the easy kind, when y is by itself or when x is by itself.
You could do 4, 0, and -4.
Right, so one of the easy numbers to use for x in this case is 0. That's the easiest one to use. So if x is 0, I get y equals negative 3/4 times x, and what's x here?
0,
And then plus 2, and then what's negative 3/4 times 0?
0,
And 0 plus 2 is
2.
2, okay? So then you would plot the point 0, 2. Then remember though, we are dealing with the fraction, and soon, the last class period, or maybe even, no, I'm sorry, probably today, we're going to talk about that, see where that negative 3/4, that's understood to be the slope. So, but for right now, let's talk about the coefficient. Let's refer to it as a coefficient of x. You have a fraction, right? So some nice numbers to use for x would be numbers that are multiples or divisible by 4, the denominator. So what will be some numbers, some nice number to use for x? 4, negative 4, 8, negative 8, 16, I'm sorry, 12, negative 12, and so on, right? All right. So, but you want to make sure that whatever grid line I give you or coordinate plane I give you, the point, you want to make sure the point lies within that coordinate plane. So you want to pick a big number for x. So let's just pick 4. So if x is 4, I get y equals negative 3/4 times 4 plus 2. Now remember, some of you have an issue with multiplying fractions. So if you need to, you may want to write that 4 as 4/1. And I'm circling these two fractions that are multiplied. The best thing to do is to reduce first and then multiply. So I can reduce the 4s. If you don't remember how to reduce, then just multiply the numerators together, multiply the denominators together, and then reduce. But basically all you're saying is 4 into 4 is 1, 4 into 4 is 1, right? And what's negative 3 times 1? And what's 1 times 1?
1.
And so what is negative 3 times 1? And what's negative 3 plus 2? Negative 1. All right, so then I'll plot the point for negative 1. And then if I choose negative 4 for x, I get y equals negative 3/4 times negative 4/1 plus 2. Now remember, a negative times a negative is a positive. So this time, these two fractions are multiplying together. The 4 goes into 4 one time, 4 goes into negative 4, negative 1 time. So what's a negative 3 times a negative 1 though?
3.
Positive 3, and what's 3 plus 2?
5.
All right. So remember though, if you did this correctly, all those 3 points should lie in the same, or they better lie in the same line. So I'm doing this by hand though, so if you do this by hand, now the one in your worksheet, I gave you a coordinate plane. The one in your tests or your final will also have a coordinate plane, but I'm doing this by hand. So if you do it by hand, just make sure you scale it as best you can. So 0, 2 is going to lie where? On the y-axis. So remember, you start the origin, x is 0, you stay there, y is positive 2, you go up 2. All right, now remember if it says label, not only do you put a dot there, but you got to tell me what the coordinates are. So you'd say coordinates are 0, 2, and with parentheses. 4, -1 is in what quadrant? Remember your quadrants, this is quadrant 1. You go counterclockwise. 1, 2, 3, 4. So quadrant 4, right? All right, so here's the point right here, 4, -1. And the -4, 5 is in what quadrant?
2.
2, so 1, 2, 3, 4. So -4, 5, 3, 4. I'm not scaling it very well. But let's say it's right here. All right, so there's the point -4, 5. And then you just use a straight edge. Do the best you can. All right, I didn't scale very well. Huh?
I make my dots bigger.
Yeah, the one in your on your worksheet or the test that already have a coordinate plane there, so it'll work out. Here, I noticed that some areas where it's not scaled the same all the way. All right, so then we also talked about this. All right, so we had, let's say we had 2, y plus 2x equal, let's say, 3. Y plus 2x equal 3. Remember we talked about how to deal with this when we discussed that section. What might you want to do here?
Subtract 2x.
All right, so in other words, get y by itself. All right, get y by itself. So to get y by itself, you subtract 2x from both sides. And so I get y equals, and let's put the variable first. So it'll be -2x and then plus 3. And then you do your t-table. All right, you do your t-table.
Now let's just use the 1, 0, -1.
Yeah, you could use, yeah. So you could say 0, 1, -1 if you want to. And so if x is 0, I get y equals -2 times 0 plus 3. And what's -2 times 0? And 0 plus 3 is 3. All right, and then if x is 1, I get y equals -2 times 1 plus 3. So that's -2 plus 3, which is 1. If x is -1, I get y equals -2 times -1 plus 3. Now what's -2 times -1?
2.
And 2 plus 3 is
5.
5. And then you would plot those 3 points. All right, so 0, 3 is on the positive y-axis. Remember, it says label. You know, when it says label, I mean tell me what the coordinates are. 1, 1 is in the first quadrant. -1, 5 is in the second. And then you just connect your dots. Make sure you use arrows. And so there's the line. All right. So those 3 points line the same line. All right, number 3. All right, number 3, suppose you had this. Suppose you had x minus y equal -4. Yeah, what would be the best thing to get by itself, though? The x. Because x has the coefficient being 1, whereas y is a -1. So let's just bring the y to the other side. So I'm going to add y to both sides. And so I get, that's a y right here. So I get x equal what, though?
Y minus 4.
Okay, good. All right, now do the t-table again. Now notice, though, you see when I did the previous 2, I plugged numbers into what letter first? X, and solve for y, because y was by itself, right? What letter's by itself here? X. I'm going to plug numbers into what? Y. So since I don't have any fractions, then again, you can use 0, 1, negative 1 if you want to. But I'm going to put on which column?
On the Y.
The y column. So 0, negative 1, 1.
It's easier doing those numbers.
Sure, it is. Okay, so if y is 0, I get x equals 0 minus 4, which is what? So there's your x coordinate. If y is negative 1, I get x equal negative 1 minus 4. Use your calculator if you need to. What's negative 1 subtract 4? Negative 5. And if x is positive 1, I'm sorry, if y is positive 1, I get x equal 1 minus 4, which is a negative 3. All right, and then you plot those 3 points. And so I get negative 4, 0, which is located where?
X-axis.
On the x-axis, the negative part of it. So 1, 2, 3, 4. So there's a point, negative 4, 0. Negative 5, negative 1 is in the third quadrant, right? And then negative 3, 1 is in the second quadrant. And then you get this line. Okay? All right, now notice when we did those 3 problems, if you go back to the notes from last class period, how many variables were involved in this equation? How many variables do you see? What variables do you see? Come on, guys, what variables do you see? An x and a y. All right? All 3 of them had an x and a y. Okay? Now, what if, and this is new, but it's still in that same section. What if you had this, y equal 6? I want to just graph this line. It is linear. You don't see the letter x. It doesn't matter. It is still linear because you see y to what power? The first. But there's no x there. All right. Now, when we did this, this says y depends on whatever x is. So whatever I plugged into x determined what y was, right? Y depends on whatever number I substitute into x. So y varies. So notice y changed each time. When x is 0, what was y? 3. When x was 1, what is y? 1, and so on. Here, x depended on whatever I substituted to y. So when y changed, x changed. Here, this says y is always going to equal what? 6. There's no x. So no matter what I use for x, y will always equal what? 6. Okay, notice y always is 6, no matter what x is. I'm still want to grab this in the coordinate plane. Now remember, in the coordinate plane, what are your axes? An x and a y. So if I graph this line, using a t-table, I've got to determine what an x and the y coordinates are. You may say, well, there's no x coordinate. How can you determine the x coordinate? It doesn't matter. Y is always going to be what? 6, no matter what x is. So when I look at the t-table, this column right here is always going to be what? 6, all the way down, no matter what x is. So if x is 0, what's y? If x is 2, what's y? If x is negative 3, what's y? And so on. So whenever there's just one variable, and students get a little confused with that. They can graph a line where there are 2 variables, but when there's one, they get confused. And you really shouldn't, because this says y always equals what? 6. So in your t-table, you just put 6 all the way down the column y and pick numbers for x. And notice what happens when I graph this. 0, 6 is here. 2, 6 is here. Negative 3, 6 is here. Notice it is a line, but what kind of line is this? Yeah, it was when it does this, it's either starts with an H. You remember what that word is? Horizontal. So it's a horizontal line. So when we talked about this right here, we said that this was 2 variables, correct? An X and a Y. Notice the line. The line was slanted. Here, now remember, you read it. You're going to learn that you're going to read this graph from left to right. So when I go from left to right, this line is rising. Rising. See how it's rising? Okay. But you have 2 variables. Here you have 2 variables, and as you go from left to right, your line is what? Falling. Okay? But it's slanted. When you have 2 variables, involved, your line's either going to rise or it's going to what? Fall. When it's 1 variable and it's y, it's what kind of line? Horizontal. What if you had x equals 6? So we know what y equals 6 look like. It's the same idea. This says that x is always going to equal what? 6 this time, no matter what y is. So in words, this says x always equals 6, no matter what y is. So your t-table, where's 6 going to be located? Which column? The x column. So you have 6 all the way down. And then y could be anything. Y could be 0, y could be 2, y could be -1, and so on. And so when I graph this line in the coordinate plane, 6, 0 is here, 6, 2 is here, 6, -1 is here. Notice it's a line that goes up and down. What is that line called? It's called the vertical line. Now, when we talk about slope soon, you're going to see that these slopes mean something here. All right, so if there's an x and a y involved, the line is slanted, either rises or falls. If it's just y, it's horizontal. And if it's just x, it's vertical. And it's kind of easy to remember because, look, y equals 6 is horizontal, and it crosses the y-axis where? At 6. X equals 6 is vertical. It crosses the x-axis at what? 6. All right? So just kind of try and remember some of these ideas. Okay, so that worksheet, if you look at worksheet 10.2 part B, take that one out. You need to, that table, that second last table, is where all those handouts are.
Okay. Thank you.
So this 10.2 part B is what we just talked about. So I want you to look on that very last 2, the E and the F. So E is going to be what kind of line? X equal 3. Vertical. F is going to be what kind of line? Y equal -5 will be horizontal. Okay? All right, so don't forget, though, there's A through F here. Okay? All right, so that takes care of that B. Okay, any questions? Okay. All right, now, something new. So this is section 10.3. And this is where we start talking about intercepts. Intercepts. in the previous section that we just did, we graphed the lines using a t-table, correct? We graphed the line using a t-table. You could also graph lines using intercepts. Intercepts. Now, what I mean by intercepts are these. So I'm talking about the X intercept, and I'm talking about the Y-intercept. And the X-intercept is where the graph crosses the x-axis, And we are talking about lines here, but we'll say graph, where the graph crosses the x-axis. And the Y-intercept is the point where the graph crosses the y-axis. All right, now, something important you got to know, and that's going to help you, is this. So if I look at this plane right here, the coordinate plane, and let's talk about the x-intercept. Remember, the x-intercept is where the graph crosses the x-axis. So if I'm just looking at lines, if I look at all these lines right here, this line crosses the x-axis here, this line crosses the x-axis here, this line crosses the x-axis here, and so on. All of these have the same coordinate. What's that coordinate? What's that number? 0 for which letter? X. Okay, good. No matter where I'm at here, X is always going to be what? 0. Y is going to be different, but notice that they all have something in common, and what they have in common is that X has to be 0. So when we do these problems in a little while, and it's very simple, when we do these problems in a little while, if you're going to find the X-intercept, I'm sorry. Is this correct? Was this correct? Yeah, but yeah, but it's not correct, right?
No.
All right, let's do this again. Let's talk about this again. All right, no matter where I am on the x-axis, it is not the x coordinates going to be the same. It's going to be what's the same? The y coordinate. Y'all agree?
Yes.
Because this could be -4, 0. This could be what? -3, 0. This could be 1, 0. This could be 2, 0, or whatever. Okay, so be careful. So to find the x-intercept, the y has to be what? 0. So to find the x-intercept, you're going to let y equal 0. To find the x-intercept, you're going to let y equal 0. And it's very simple to remember. Just do what we just did, although we weren't thinking very clearly here. But no matter where you are on the x-axis, y is always 0. So you're going to see in a little while that if you want to find the x-intercept, you're going to let y equal 0. And so if we look at the y-intercept, let's do the same thing. And let's say I have these lines right here. Remember, the y-intercept is where the graph crosses the y-axis. This time, though, if I look at these points, which of these coordinates is 0? The x. So all the way here, they all have something in common. And what the y-intercepts have in common is that x has to be what? 0. So if we want to find the y-intercept, I'm going to let x equal 0. To find the y-intercept, you let x equal 0. Okay? All right, now, worksheet 10.3, Part A, Let's talk about that. Okay, so let's look at these examples. Okay, so we're going to graph these lines using intercepts. Graph each line using intercepts. Right, very simple. All right, number one, let's suppose we had this. Suppose we had x minus y equal 6. X minus y equal 6. Now, don't use a t-table. I want you to use the idea of intercepts. Okay, so don't do this the way we did in the previous section. So in your mind, you're just going to say this, or you're actually going to write this out. You're going to say, all right, the first thing we do is find the x-intercept. To find the x-intercept, what do you say? Yes, y equals 0. That's what you're going to say. Now, if y is equal to 0, do you all agree that this term goes away? That y term? No,
I don't know.
okay, well, what is y here? 0. So if y is 0, x minus 0 is just what? Is just x. So what I'm saying is that if x is 0, y is what? I'm sorry, if y is 0, this term is what? 0, and it kind of like it disappears because x minus 0 is still what? X. So what equation is left? So basically what you can do is just put your thumb over the term that's now 0 and tell me the equation that's left. X equals 6, and there's your x-intercept. That's your x-intercept. Now, sometimes the directions will say this, and it does here. It'll say list the intercepts as an ordered pair. So an ordered pair, remember an ordered pair means an x and a what? A y. So as an ordered pair, x is what here? 6. Y is what? 0. So that's what I mean, right? Okay. As the ordered pair. So 6, 0. All right, and then to find the y-intercept, you say let what? X equals 0. All right, now, if x is 0, this term right here is 0. I'm covering it up. But what equation is left? Negative y equals 6. But you got to get what letter by itself? Y. So remember how we did this. If you need to, write this as negative 1y equals 6. And then one more step and you're done. How do you get y by itself? Yep. And so what's your y-intercept? Negative 6. What is that as an ordered pair? 0, negative 6. And then all you do is just plot those 2 points, draw your line, you're done. Plot those 2 points. So remember, 6, 0 is the x-intercept. So that's where the graph's going to cross the x-axis. 1, 2, 3, 4, 5, 6. 0, negative 6 is where the graph's going to cross the y-axis. And then use a straight edge. So in your test and final, I will have a ruler for you. And that's it. I graphed this line by just using what? Intercepts. That's all they wanted. Okay?
When we did the lines like this, like when I guess kind of going to infinity, we won't do that either. Like right here. Because it looked like these.
Oh no, I was just
no,
I was just trying to explain that no matter where you are on the x-axis,
Okay.
the y-coordinate is always going to be 0. That's all that was.
Okay, thank you.
Mm-hmm. All right, and let's look at this. So that's number 1. That's all that was about. Number 2. All right, suppose you had y equal 2x minus 4.
You cover up the 2x?
Huh?
You cover up the 2x?
Well, okay, so remember, don't follow the directions. Directions said use intercepts, right? So don't go directly to the t-table and say I'm going to let x be 0, 1, -1. That's not what they want you to do here. They want you to use the idea of intercepts. Always follow the directions. So if I want to use intercepts, I'm going to say, well, first of all, let me find the X-intercept. Find the X-intercept. So always write that down. It does help. Find the X-intercept. I let what? Y equals 0. Now be careful. If I put my thumb over the y, what equation is left? What equation do you see?
2x minus 4.
Okay, it has to be an equation. 2x minus 4 equals what? 0, because that's what y is, right? Okay, so in other words, you're saying 0 equals 2x minus 4. Do y'all agree? All right, and then all you got to do now is just get x by itself. So how do you solve for x?
Add 4 to both sides.
Add 4 to both sides. So I get 4 equals 2x. One more step and you found the x-intercept. What's the next step? Divide by 2. So what's your x-intercept? 2. What is that as an ordered pair?
2, 0.
2, 0. All right, now let's find. So you can say find y-intercept, let x equals 0, right? So this time if x is 0, the 2x becomes what?
0.
0. What equation do you see?
Y equals 0 minus 4.
Which is y equals what? -4. So 0, yeah, y equals 0 minus 4, which is y equals -4. So there's your y-intercept. As an ordered pair, what is that y-intercept?
0, -4.
0, -4. You plot the 2 points, and you're done. So 2, 0 is here. 0, -4 is here. And there's your line. Okay? There's your line. All right, now let's look at this one. Okay, suppose you had this one, number 3. And that's going to help you with number 6. So I'm going to do one like number 6. So let's suppose you had what? Y equal Justin. I'll be bringing some coffee next time, dude.
Finals, that's all.
Y equal 3x. Y equal 3x. So the only first of all, notice that numbers 1 and 2, not only did you have an x and a y, but you had a constant. Number 3, you have an x and a y, but you're missing a what? A constant. So let's just see what happens. So we're going to do the same thing. We're going to find the x and y intercept. And you're going to see this kind of problem on my math lab also. So to find the x-intercept, you let what?
Y equals 0.
Y equals 0. So if I let y equals 0, then that says this y right here becomes what? 0. So you get 0 equals 3x, and then how to get x by itself? Divide by 3, and so what's the x-intercept? 0. 0 divided by 3 is 0. What ordered pair is that, though?
0,
0, 0. That's the origin. But notice what happens. To find the y-intercept, I'll let what? X equals 0. When x is 0, I get y equals 3 times 0, which is just what? What do you notice about those x and y intercepts? They're the same. But in the other two, the x and y intercepts were distinct. Here, the x intercepts are the same. So really, I can't grab that line just yet, because notice what happens. I only have how many points? Just one. So my math lab is just going to say just find another point on the line. So in other words, use the t-table. So give me a number for x. You just need one more point. Give me a number for x. 1. If x is 1, I get y equals 3 times 1, which is just what?
3.
All right, and then you can graph the line. So there is going to be a situation in my math lab where the x and y coordinate is going to be the origin. You just have to use the t-table to find another point. So 1, 3 is here. And there's your line. Okay? All right, so for that one, make sure you put in there to do the last class period. So 10.3 Part A, last class period. All right, so right now you can do all the stuff that we just talked about, all those worksheets. Now, there's some other worksheets you picked up we haven't done yet, but is the others is not going to be due the last class period, but we do need to talk about it because it could be on your final. So we'll get to that point, okay? All right, but definitely those that we just talked about is due when? Last class period. And I'll send an email about what to do. Okay, so